Operations with radicals, Unit 3, Lesson 4. So another word for radical is root. Okay, you can take the square root, and this part right here is called the radical sign. Right, and when there's like a 2 there, we call it the square root sign, or we change it to a 3, and that's called a cube root sign. Okay, so what are radical expressions? What is considered to be a mixed radical, and what is an entire radical? So radical expressions have roots in them. Okay, so example, you have the mixed radical. So meaning you have the radical portion, the square root, the root portion, and along with the number. So equals 2 square root 3. That's a mixed radical, right? And example, an entire radical, and another word for it could be an improper radical, is when you have square root of 12, the root of 12. Well, the reason that is an improper radical is because, well, what is 12 divisible by? Well, there are other numbers like 2 and 6 and 1 and 12, but is it divisible by a perfect square? And yes, it is. And so it is divisible by, well, 4 and 3. And so you can break that apart within, or you can write it so that it's under the square root, like separately. So there are 2 ways of writing that. Well, can this be simplified to a mixed radical? And it can. Square root of 4 is 2. And so as a mixed radical, it is written as 2 square root 3. Okay, so notice that as we're talking about these mixed radicals and improper radicals or mixed radicals or entire radical, they do remind us of fractions. So they're like fractions. So why learn about them? Okay, the reason is prior we might have been okay to leave it as square root 12, okay? But what we need to do is that we're always reducing and simplifying it if possible, right? So it's like fractions. Well, you could have left it as 6 over 12, but you should reduce it to 3 over 2. So you must not round answers when working with questions in math. So except, well, when are acceptable situations that you are working with round numbers? When you are graphing, so except when graphing. And what's another situation? When you're dealing with word problems. So you need to, know how to reduce and simplify root expressions. So the following is very algebraic, right? So when simplifying radicals, it is important to know the perfect square numbers as they will help you to reduce the entire radical into a mixed form. List the first few perfect square numbers. Well, notice that it worked out because that 4 was a perfect square. So we should list out all of our perfect squares. So we start off from 1, but we don't really need the 1. Why is that? Well, it doesn't really help us simplify. So I'll cross that off later. Next, so 1. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 39. 64, 81. 10 squared is 100. 11 squared is 121. 144 is 12 squared. 169 is 13 squared, etc. And you could even reduce if any of these are under the square roots. What are the steps of simplifying and reducing radicals? Okay, so first, you're going to find what kind of perfect square? Or are you going to pick the smallest? Or are you going to pick the largest? Or you're going to pick the largest. You're going to pick the largest, find the biggest perfect square that divides into the given radical. Okay. Part 2, or step 2. Find the biggest perfect square that divides into the given radical. So once you've done that, you need to, well, if you notice over here, what did I have to do? I kind of broke it apart. So I broke the 12 into a 4 and 3 because the 12 was divisible by 4, a perfect square. So 4 times 3. So I want to break it apart. So I want to simplify by writing separate roots on each factor. So must be multiplication or division. Okay, so hopefully that will make more sense as we're actually doing them. So if the number under your radical cannot be divided evenly by any of the perfect squares, your radical is, well, if I have a square root of 3, or square root of 7, square root of 91, square root of 5, okay, I can say that that is already reduced. So I don't need to reduce it any further. If you do not choose the largest perfect square to start the process, you will have to repeat the process. Okay, and that's okay. We're just taking more steps as we do that if we do that. So let's go through some of the more simple examples. So square root of 147. What can I divide that by? Right, so I'm taking a look at my list of perfect squares from question 3 and kind of mentally going through it, or you could use a calculator. Once you've done that, you should notice that it is divisible by, okay, well, you might try different things. Like, let's say you said, oh, a 7 and 21. Well, that's valid. 147 is divisible by 7, and 147 is divisible by 7 and 21. So those are the factors, right? But is that helpful for us? No, because none of them are perfect squares. So I can't simplify that square root of that factor into something simpler. So I'm going to write not helpful if 7 or 21 is not a perfect square. So square root of 147, so you have to go back to the list, try to divide it by 4, 9, 16, etc., 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 and then you should stop at a certain number. Okay, so in my case, I got square root of 49 and square root of 3 to work out, because 3 times 49, or 49 times 3, does equal 147. Well, how does that help us? Square root of 49 is 7. So as a mixed radical, the answer is 7 square root 3. So for 3 equals square root 32, what are two numbers that are divisible by 32? And try to think of one that's a perfect square. So you might have thought of 8 and 4, or you might have thought of 16 and 2. So we're going to try to kind of show both ways. They're both right, except one's going to have an extra step. Is it wrong? No. So simplest thing that's in our head is probably the 4 and the 8. All right? And square root of 4 is equal to 2. So I'm going to write 3 bracket 2 square root 8. What's 3 times 2? 6, and then square root 8. Does this reduce anymore? Well, do a little check. 8. Well, 8 is actually divisible by 4. So you have to do it again. So you have to repeat the process. That's what it means. Repeat the process. I need to reduce. Next, I have, well, 8 is divisible by 4 and 2. So 6, break that 8 into 4 and 2. And I have to keep it under the square root. And so square root of 4 is 2. 6 times 2 is 12. So 12 square root 2. That is the mixed radical. So you could have done it, maybe you got it on the first try, you would have gotten 3 and have recognized that 32 is actually divisible by 16 and 2. And you would have done 16, square root of 16 and 2. Square root of 16 is equal to 4. So 3, 4, square root 2 is equal to 12, square root 2. Notice that it's the same answer. So for part B, compare your answer, and I'll do D together. So these ones have some variables included to it. And so what you can do is try to break it apart. So let's see. Square root of 200. So that breaks apart to 102. A4, well, you could break it apart right away like this. But for B3 has an odd exponent. And so I want to remove any even exponents like 2, 4, 6 out of it. So how do I break that apart? I could break it into a B2 and a B1 because B3 separates to B2 and B1 under the square roots because B2 times B1 equals B3. So let's go through it. 100, square root of 100 is 10. Keep the square root 2 because that's not going to be a whole number when you do it, right? It's the decimals, and the reason why we're trying to simplify it, we want to get these exact answers in simplified mode. Square root of A4 is A2, and then square root of B2 is B. Is that clear on why? Sometimes the square root function can be written in this way. So if you take the square root of A4, when there's no number there explicitly, there's a 2, a tiny 2 there. And when you are dealing with the square root function, keep in mind another way to write that is as an exponent. So that could actually be written as 1 over 2. And so by power of a power rule, if you applied that, it states to multiply the exponents. And A4, so 4 times a half is 2. So that's why square root of A4 is equal to A2. And what two numbers multiply to A4 exactly? Well, A2. Okay. So are we done? Let's see. Square root of B squared is B, but I still need to keep that B. I'm going to grab all the terms and that do not have the square root, so it'll be 10a squared b, and then square root of, so put the 2 and the b together, so it's 2b. Okay. Next, what are the steps of adding and subtracting radicals. So first, you should reduce plus simplify each item. So just make sure that each term is simplified, and then you're going to add / subtract like radicals. Example, if you have 2 square root 3 and, so that suggests adding 5 square root 3, that is equal to what? What do you think? When you add them, it is equal to, what you do is, it's like you have 2 of something and 5 of something. Well, if you have 2 of chocolate bars and 5 of chocolate bars, you have 7 of the chocolate bars. So I'm going to put that together by writing 7 square root of 3. And I'm not going to write it as 7 square root 6. The 3 and the 3, the square root 3, it's like the x, right? You're going to combine it so that it's like 2x plus 5x equals 7x. We're not going to suddenly say that the 3's are going to combine and say 7 square root 6. So we don't want that. So when you are dealing with adding and subtracting, only the coefficient changes. So for example, 2x and 5x, so and suggests plus. So just like I mentioned, 2x plus 5x is 7x. So it's like we're dealing with the square root part as like an x. We're dealing with it as like an x. So therefore, like polynomials. Okay, moving down. So we need to simplify each part, so each term. The square root of 12, well, that breaks into square root 4, square root 3. What about 2 square root 48? So go to your perfect square list. And it is divisible by 4 and 16. But between the two, 16 is bigger. So I'm going to say 2 square root 16 and not 4, but 3. So 16 times 3 equals 48. For the 175, well, it is divisible by 5, but 5 is not on the list. It is divisible by 25, and so I'm going to write 25, and 175 divided by 25 is 7. All right, simplify each term. Square root of 4 is 2, square root 3 plus square root of 16 is equal to 8, so 2 times, oh sorry, not 8, square root of 16 is 4, so 2 times 4, square root 3, minus 5, square root of 25 is 5, square root 7. Simplify. So we have 2 square root 3 plus 2 times 4 is 8, square root 3 minus 5 times 5 is 25, square root 7. So when you look at that, it's like you're collecting like terms, right? Which ones have the same radical portion? Well, if you notice, these are the same, so I can combine them, but I can't combine the third term. And so I have to add the coefficient, so 2 plus 8 is 10, square root 3 minus 25, square root 7. So can I simplify this any further? What do you think? Well, it's like you have equals 10x minus 25y. Can you simplify it in that case? You can't. You can't do any more because you're not dealing with like a common radical. Next, part B. Do the same thing. Equals 2 square root of 18 can be broken down to, 9, and 2. Square root of 12 can be broken down to 4 and 3. Keep the 4. Square root of 50 is going to be broken down to the perfect square, 25, and the number 2. 27. 27 is divisible by a perfect square, 9, and 3. So 2 times, well, square root of 9 is 3. 3 times square root of 4 is 2. 4 times square root of 25 is 5. 4 times 5, square root of 2, plus square root of 9 is 3. Okay, simplify. 2 times 3 is 6, square root 2. 3 times 2 is 6, square root 3. 4 times 5 is 20, square root 2, plus 3, square root 3. Can I simplify this any further? Yes, I can. And are there any other parts that can be combined? Yes, there is. And so I have 6 square root 2 plus 20 square root 2. 20 plus 6 is 26 square root 2. Minus 6 plus 3 square root 3 is minus 3 square root 3. And am I done? And just like before, I can't combine anymore because we're dealing with 2 different radicals. What are the steps of multiplying radicals? 1, we need to reduce like we had for when we were adding and subtracting radicals. Second, we can multiply coefficients separately from roots. So for example, we have 2 square root 3 times 6 square root 2. 2 times 6 is 12, so 2 times 6. And then I'm explicitly kind of showing you the breakdown. 2 times 6 is 12. 3 times 2 is 6. Part 3, we're going to reduce. And in terms of step 1, we could skip that step because we have to reduce at the end anyways. Okay, so 3 square root 12 times 4 times square root 6. We're going to multiply the coefficients and then multiply what's under the radical or the square root. 3 times 4 is 12. 12 times 6 is 72. But keep in mind, we've done part 1 and part 2, but we have to double check on whether we can reduce. And the reason why we're able to reduce was square root 12 was able to be reduced from before. So keep in mind that that's why that happens. So we have, well, how can I reduce the 72 at this point? The way I've started off. I can recognize that I can break the 72 into 36 and 2. 36 being the biggest square, perfect square under the square root. So that reduces to 12 times 6 and then square root 2. 12 times 6 is equal to 72 square root 2. Okay, try some of these other questions and then pause the video as you need. But for now, I'll go to part C actually. So I need to distribute that 5 square root 14x into both parts of the term. So I have, 5 times 2 is 10. And then inside I have 14x squared. 5 times 4 is 20. And inside I have 14 times 7, which is 98x squared. Next, I have the 10. And I want to break it apart into factors, right? So I have 10. I have square root 14. I'm going to break that to square root x squared. minus 20. With the number, the 98, I can break it into some factors that include perfect squared. So 49 and 2, and along with the x squared. So keep in mind which parts kind of stay and which parts don't. So what I mean is that's going to go away. Well, that's going to simplify. I should be using the word simplify, not go away. So then square root of x squared is x, because those words cancel out, right? Those parts cancel out. And so I should put the 10. The x goes at the front, and then along with the square root of 14. Minus 20, square root of 49 is 7. And what else? I need to drag that x to the front and leave it as that. So I have one more step of simplifying the 20 times 7. So I have 10x square root 14 minus 140 x square root 2. Okay, part B. So keep in mind that we have FOIL going on, FOIL, and we're dealing with difference of squares. So I have, well, square root of 5 times 5 is square root 25. Square root 5 times 3 is plus square root 15. And then square root 3 times square root 5 is minus square root 15. And then minus square root 3 times square root 3 is minus square root 9. That simplifies. Meanwhile, that's equal to 5. That's equal to minus 3. And therefore, it's equal to 2. So we knew that the middle values were going to cancel out by difference of squares. And remember, difference of squares is when we have, let's see, open a new window. So difference of squares, as a reminder, is when we have a minus b, a plus b, which simplifies to a squared minus plus ab minus b squared. Those cancel out, and that's why we had that, and things canceled out. Alright, so part D. So negative 2 times 5, so we're doing FOIL again. So we have negative 10. Negative 2 times negative 5 is equal to plus 2 square root 5. Minus 3 square root 5 times 5 is, well, multiply 3 times 5. That is equal to minus 15 square root 5. And lastly, minus 3 square root 5 times minus square root 5 is equal to plus 3 square root 25. So let's see, we have minus 10. I'm noticing that the middle terms have the same radicals beside it, so I'm going to simplify that to minus 13 square root 5 and then plus square root 25. Next, I have, well, actually I could have simplified the third term to what? 3 bracket 5. So I have minus 10 minus 13 square root 5 plus 15, so that simplifies to 5 minus 13 square root 5. So something that's going to come up is the word conjugate. And so let's see if we can simplify that a little. Okay, so I'm just gonna write it on the top. Conjugate. Conjugate is when we have, example, square root 5 plus 1 the conjugate of that is square root 5, and you change the sign of the second term to the opposite one. So it's going to be square root 5 minus 1. So the conjugate of square root 5 plus 1 is square root 5 minus 1. So we need that for our side notes for the later steps.